Hello everyone, this is your review for your upcoming probability test. And so let's get started. I think number 1 and 2 are a little bit different on your paper copy. So if you want to just change the numbers, I think the numbers are different. But either way, for both of these, we have to find the total number of outcomes. And so when we do the total number of outcomes, let me do this over here. For both of these, all you have to do is multiply the probabilities. And so for example here, there's 7 exterior doors, 6 stairways. All you would say is 7 times 6. That's your total number of outcomes. For example here, it's a little bit different. He's rolling a standard six-sided number die 10 times. So, the number of outcomes for the first time is 6. For the second time, 6, 6, 6, so on and so forth. And therefore, that'd be just 6 to the 10th. So for both of these, I want you guys to find the answer and I want you to box them. Again, all you have to do here is multiply the probabilities. Anytime you're doing the number of outcomes, that's all you have to do. For numbers 3 and 4, super easy, just 6 factorial. Reminder, there is a button that does this for us on the calculator. It is the PRB button. So it says PRB, it is close to that second button. So PRB, just 6 factorial, and you should get your answer. Obviously, we don't have the same calculators, but this is what your screen should look like right before you click enter. For number 4, just reminder, let's just put these in parentheses just to be safe. You don't have to, but in case you really want to, you can go ahead and just do that. For 5 and 6, this is just permutations and combinations. We're not reading anything. We're not determining anything. You guys just have to hit that probability button. "12" goes first, hit the probability, then 3, click enter. So your screen should look a little bit like this. So here it should say 12, NCR 3, of course, if it's permutations, NPR, then just click the NPR button instead. For these, I do want you guys to go ahead and find them. So find that, evaluate that, and then just box your answer here. Find this for me, and box your answer there. Okay, let's move on. A lot of you guys during the quiz are having trouble with these, but these are super simple. It just says a random 2-digit number, 1 out of 100, is drawn. Find each probability. There's only one 32 out of 100. There's no more, so that's it. That's your answer right there. So I want you guys to write down that fraction. And that's all there is to it. There's 132 out of 100. Find me the answer and box it. For 8, you guys were having trouble with the ands here. And so, reminder, for these, all you have to do is add both the probabilities. Add both of those probabilities. So add up the probability 3 and the probability of 4. Another reminder, the bottom of the fractions, they stay the same when you add. Okay, so you're not going to be adding 100 and 100 together. Those stay the same. But other than that, all you do is add both of these. So again, for 7 and 8, do find me those answers and box them in. Let me know what those are. For numbers 9 and 10, we have something very similar like this on the test. For numbers 9 and 10, it says a day of the week was chosen at random 60 times. So 60 times. Remember that. Don't waste your time and add all these up. The results of this experiment are shown below. Number 9 says was a theoretical probability. When we're talking theoretical, we are not using any of these numbers. This is strictly in theory. So day of the week, we know that's going to be 7. And then it says day that starts with the letter S. Here's 1. Here's the other. That's going to be 2 out of 7. And so 2 out of 7 will give me, I think, 28.57%. That means the decimal was 2857. So a lot of you guys during the quiz, even though I told you I needed 2 after the decimal point, you guys didn't listen. So listen to me this time around. After you move it twice, I still want this entire thing, these 2 places after the decimal. So here your answer, how you would input it into Schoology, it would be 28.57. So for number 10, it says based on this experiment. Once it says based on this experiment, of course, now we are going to be using all of these numbers. This is experimental probability. And so theoretical, that's in theory, 1 out of 7. However, this is now 1 out of 60 times because it says based on the experiment. So I'm already just going to go ahead and write out of 60 because I know this is an experimental probability. So what is the probability of selecting a day that starts with the letter S? So we're going to get 2 different answers despite them looking really, really similar. So here I've highlighted both of the days that start with the letter S. Here it landed 4 times. Here it landed 14 times. So I'm going to add those up. So 14 plus 4, that will give me 18 out of 60, which I think is 30%. Okay. Yeah, I mean, that's it. Theoretical, do not worry about these numbers. However, when experimental comes around, then you can go ahead and worry about those numbers. So a lot of you guys were having trouble with independent and dependent events. Reminder, when it's independent, they don't have any outcome of each other. So let's take a look at these. It says a die is rolled, then a coin is tossed. You first have to determine whether it's independent or dependent. So it says a die is rolled, then a coin is tossed. So if I roll a die, that has absolutely nothing, no effect on the fact that I toss a coin afterwards. So then when it is independent, so we said that these are independent because they have no cause on each other. Let me erase this. They have no effect on each other, so I know that in order to find this, I'm going to multiply the probability of A happening multiplied by the probability of B happening. So of course here P of A, that's my first one, which is getting a 5 on a die. Okay, so a die has 6 sides. There's only one with one side with a 5 on it. Then I'm going to multiply it with my B, which is my coin toss. So of course there's only 1 out of 2 chances of me landing on a tails when I flip that. Then because I will need the percent, then I can just go ahead and do this on a calculator. You don't have to do anything other than put 1 divided by 6 multiplied by, I think that was 1 out of 2. I'm going to click enter and I'm going to get 0.833. So 0.833, but I am going to want it in a percent form, so I'm going to move this over. And so what I would be inputting, if I were taking this, what I would be inputting into Schoology would be 8.33%. Okay, that's only for independent event. For questions like number 12, a lot of you guys are having trouble on this quiz as well. We have to be able to tell if it's independent or dependent. So this says a bag contains the letters of the word Michigan. The letter is drawn, not replaced. That's important here. We are not replacing it. Anytime it says not replacing, that is a dependent event. Anytime you don't put something back, anytime you eat something, that is dependent. It does have an effect on the next outcome. So for here, I'm going to count my letters. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 in total. But the probability of both letters are I. So here I'm going to count my I's. 1, 2. So my first probability is going to be 2 out of 8. However, remember I took that letter and I did not put it back. So right away, my second should be out of 7. because I've already not replaced it. But since I already took an I, then I only have one left, 1 out of 7 in total. So after that, you just go ahead and multiply those in the calculator, get your decimal, turn it into a percent. Reminder, I need 2 decimal points, or 2 places after the decimal point for your percent. So you guys go ahead and find that for me, box it so I can see it, and we can move on. For number 13, it says, recall that a permutation is an arrangement with a specific order, while a combination is a group with no specific order. Determine whether the example represents a permutation or combination, then solve. So it says a dance company is choosing 3 new dancers from a group of 25 who try out. How many ways can they choose the new dancers? So this one we have to determine, does it have an order? Did it tell us a specific way in which we have to choose these dancers? Do they tell us, well, I want a classical dancer, and then I want a tap, I don't know, something like that. They didn't tell us anything specific. They didn't tell us I need to choose it first, second, third. They didn't tell me I had to line them up a certain way. So because of that, then I know the order does not matter. I know this is a combination. And so we need our N, and we need our R for both of these. Reminder, N is a total number, and R is going to be the number of ways they can be arranged. So put it in annotation for me, and then solve it. So annotation here equal to, and then your answer, box both of those for me. Now let's move on to number 14. And so this is going to be a geometric probability question. It says, find the probability that a point chosen randomly inside the rectangle is in each shape. And we are looking at the square here. Reminder, this is always going to go on top. So we need 2 things here. We need the area of my rectangle. In case you forgot, you find that by multiplying your length times your width. But you also need the area of your square. That's just S side squared. And so when you do that, we are going to say A squared. So whatever you get for the area of your square, that's not how you spell square at all. Let's fix this. The area of your square divided by the area of your rectangle. Then you just put those in the calculator, and you're going to get a decimal. Do leave that in decimal form, but once you do, box your answer so I can see it, and we are pretty much done. So I need you guys to find all the answers that I asked you for, and I need you to bring it back to me next class time completely finished. You will need to turn it in. It will be a grade, and so you guys can go ahead and do that, and we should be ready for our test.